Good morning, students. Welcome to our class in Physical Science. I am your teacher, Sir Roland O. Takan. How are you today? I hope that we're all doing good. Before we will start our class this morning, may I request everyone to please stand for our prayer.
Dear Lord, we thank you for the gift of life today. You allow us to have another day to praise you and see your glory. Thank you for the love and protection, especially this time of pandemic. Bless us, Father, with your wisdom as we begin our class. Help us to focus our hearts and minds on what we are about to learn. Inspire us by your Holy Spirit as we think and listen. Guide us by your eternal light as we discover more about the world around us. Lord, we thank you and let your will be done in our lives. We ask all this in the mighty name of Jesus. Amen.
Again, good morning, students. Before you will take your seats, kindly pick up pieces of papers under your chairs and arrange your chairs properly. You may now take your seats. So let us check the attendance. Mary Ann, who are absent for today? Very good. There is no absent. To formally start our class discussion this morning, please be reminded of the following house rules. I want you to read this one. Before we will discuss our new lesson this morning, let's have first a sort of review. Question: what is the difference between propagation of light, reflection, and refraction? Jean? Very good. That is the correct answer. When we talk about propagation of light, it refers to the manner in which an electromagnetic wave transfers its energy from one point to another. Refraction, the bending of light, it also happens with sound, water, and other waves as it passes from one transparent substance into another. This bending by refraction makes it possible for us to have lenses, magnifying glasses, prisms, and rainbows. And last, reflection. This refers to the change in direction of a wave at boundary between two different media, so that the wave moves back into the medium it came from. The most common examples include the reflection of light, sound, and water waves. Is there any questions with regards to our previous lessons? None? If there's none, let's proceed to our pretest. I have prepared here a multiple choice. Directions. Read each statement and choose the best answer by writing the letter of your choice. Write your answers in a clean sheet of paper. Are you ready? Okay, let's begin. Question number 1. Davison and Germer scattered electrons from a crystal of nickel. The scattered electrons form a strong diffraction pattern. What important conclusions will be drawn from this experiment? A. Electrons acted like waves. B. Neutrons acted like waves. C. Protons acted like waves. And D. All of the above. Start! Time is up. The correct answer is letter A. Very good. Let's proceed to the second question. Light bends around sharp corners as a result of A. Refraction, B. reflection, C. diffraction, and D. dispersion. Start! Time is up, and the correct answer is letter C. Very good. Let's proceed to the third one. Two waves of equal wavelength will interfere destructively most effectively under one of the following conditions. Will the interference be most effective when the waves are A. in phase and have equal amplitudes, B. in phase and have unequal amplitudes, letter C. 180 degrees out of phase and have equal amplitudes, and letter D. 180 degrees out of phase and have unequal amplitudes. Begin! Time is up, and the correct answer is letter A. Very good. Number 4. Diffraction and interference demonstrate which of the following? A. Particle nature of light, B. Wave nature of light, C. Polarization of light, and D. Reflection of light. Start! Time is up, and the correct answer is letter A. The last question. It is a line straight to curve that is perpendicular to live wave fronts. Its tangent is collinear with the wave vector. A. Refraction, B. Reflection, C. Diffraction, and D. Dispersion. And the correct answer is letter B. Congratulations, students, for the job well done. Let's give a hand to everyone, please. This time, let's have an activity, and this is called Search It. I will be giving you 3 minutes to answer this one. Directions. Take a look, find in the puzzle of the different terms that best describe the given definitions below. Find the word by inserting the term in the box. Number 1. The bending of light when it encounters an obstacle or an opening. Number 2. The result of the superposing of waves from different sources. Number 3. The separation of white light into its 7 color components when there is a refraction or bending of light. And number 4, the ability of particles to absorb light and scatter in all directions. The time starts now. Time is up. Let's check your answers, students. So this is now the correct answer. I will reveal it to all of you. Okay? See this one. Very good. For number 1, the answer is diffraction. Number 2, the answer is interference. Number 3, the answer is dispersion. And last, number 4 is scattering. Okay, let's check who got the perfect score. Anybody from the group? Wow, it's amazing, students. So what would be our discussion this morning is all about? Anyone from the group who can answer me? Yes, Nicole. What would be our topic for this morning? Very good, you've got it. Our discussion this morning will focus on Quarter 4, Module 4, dispersion, scattering, interference, and diffraction. To know more, I want you to take a look with our objectives. We have here our objectives. We have our learning competency, differentiate dispersion, scattering, interference, and diffraction. And our specific objective, differentiate dispersion, scattering, interference, and diffraction. And number 2, compare and contrast dispersion, scattering, interference, and diffraction. And that would be the focus of our lesson for this morning. Is it clear, students? Okay. Do you want to play? Or a game? Yes, I'm sure you are excited with this. So this time, let's have an activity. And this activity is called Picture Game Analysis. Since you already grouped into 3, you have the leader, you have the secretary, and you have the reporter. So what you are going to do is to identify and determine the picture that I will be showing to you. And you are going to identify or determine what this picture is all about. And after which, you are going to answer the guide questions later. Clear? And of course, in every group, you are given 2 minutes to present your output. So that would be the reporter will be the one to report here in front. Is it clear? Are you ready, students? Yes, I am also ready, students. First picture. Now, let's proceed to the second picture. Third picture. And the last picture. So you are going to determine and identify what is this picture is all about. So these are the guide questions that you are going to answer. Number 1. Based on the picture analysis game, determine which picture is considered as A. Diffraction, B. Interference, C. Dispersion, and last, the scattering of light. Question number 2. Differentiate dispersion to scattering of light, diffraction, and interference. And last question will be, what happens if dispersion and scattering of light do not occur? The time starts now. Okay, is there any questions, students? Are you all okay with your activity? I know that you really enjoy this activity. Okay, you still have 5 minutes? Okay, students, you still have 1 minute more to go. Okay, I hope that you are doing good with your activity. 30 seconds time more to go. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Time is up! Okay, congratulations to each group for the job well done. Before the presentation, I want you to be guided in rating your group with this type of rubric. Rubric for group presentation. So please be guided in giving the rate or score to your other group. Okay? Is it clear, students? I hope so. So this time, let's proceed to the presentation of output for each group. Let's start with the group 1. Good job, Group 1, for that amazing answer and observation based on the activity that we have. Let's proceed to the group number 2. Very good, Group 2. That is amazing performance. And now, the last but not the least, the Group 3. May I request the leader to please report your output. Okay, congratulations Group 3. So let's give a hand to every groups. Congratulations for that very wonderful and amazing answer of your group in each activity. So this time, I will reveal to you the answers if your answer is correct. Let's do it right now. This is now the answer of the picture game analysis. Picture A, that is for dispersion or the picture 1. Picture 2 is diffraction. For picture C or number 3 picture, that is an example of scattering of light. And picture D or picture number 4, that is an example of interference. So we already answered question number 1. So let's proceed to the second guide question. Differentiate dispersion to scattering of light, diffraction, and interference. Who can give me the answer? Yes, Juan. Very good. When we talk about dispersion of light, that is considered as the separation of light wherein the light is being dispersed. When we talk about scattering of light, that is the ability to absorb light and the light is being scattered. And diffraction, that is the bending of light wherein the light will bend when there is a barrier. And the interference, that is the superposing of waves from different sources. And guide question number 3. What happens if dispersion and scattering of light do not occur? Yes, Marichu. Very good answer. If dispersion does not occur in nature, then there is no rainbow formation and splitting of light into 7 different colors. If there is no scattering, then the oceans and sky appears to be black. That is answer number 3. As we go along with our discussion this morning, all of those questions will be answered, of course. So let's proceed now to our lesson discussion or lesson proper. When we talk about dispersion class, this is the separation of white light into its 7 color components when there is a refraction or bending of light. So when we talk about dispersion, the light is being what? Separated into 7 colors. So this is an example class. We have here the glass prism, the white light, and the white light is being passing through into the glass prism. What happened? There are 7 colors being produced. The Roy G. Viv colors. Okay? Okay, class. It is clear and understood? Very good. Going back to the example that I had presented to you, class, about the white light passing through the glass prism. The white light is composed of the different color spectrum: red, orange, yellow, green, blue, indigo, and violet. Each color has its own wave frequency. Remember, each color has its own wave frequency. Different light frequencies bend at different amounts when they pass through a prism. When white light passes through a prism, it will refract 2 times, making the separation of the colors noticeable. So that is an example wherein the white light passing through the prism, wherein it produces 7 colors. Clear? So this is now an example of dispersion. Yes. It forms what? Different colors. That is a rainbow in the sky. Another one, that is also a dispersion of light. And the last one is also an example of dispersion of light. Talking about scattering of light, this is different from dispersion. When we talk about scattering of light, this is the ability of particles to absorb light and scatter in all directions. So what really happened here is that the light is being absorbed, and once the light is absorbed, this will be what? Scattered into different areas. Scattering of light components depends on the size of the particles or scatterers. Small particles scatter components of short wavelengths, high frequency, while large particles, longer wavelengths or low frequency. There are two terms that we are going to remember in scattering of light. Short wavelengths, it means to say there is a high frequency, right? And when there is a longer wavelength, there will be a low frequency of light. Clear? So this is now an example of scattering of light. Please see this one. Okay, so as what you have noticed, that the light is being scattered. Another example, the sunrise, wherein the rays are being scattered, and this one also, that is being scattered. Going back to the discussion in the scattering of light, our atmosphere is composed of tiny particles that scatter color components of white light. The atmosphere has an abundance in nitrogen and oxygen, which can scatter high-frequency components of white light. These scatter violet the most, followed by blue, green, and so on. This selective scattering is called Rayleigh scattering. Our eyes are more sensitive to blue frequencies of light, which is why we see the sky as blue. So, clear? So that is the discussion in the scattering of light. So let's proceed now to the third one. This is called diffraction. When we talk about diffraction class, this is the bending of light when it encounters an obstacle or an opening. A shadow is usually formed when light meets an obstacle. The bending of light is not very much noticeable, but when you look around the edge of the rainbow or the shadow, you will notice blurred areas or diffraction fringes. These are the areas where diffraction of light occur. So talking about diffraction, the light that will pass through in the straight line and it will undergo the so-called barrier that will trap the light is being diffracted, and that is called as diffraction. So this is an illustration of the diffraction. So you have there A, B, C, D, and E. So that illustration is that the amount of diffraction depends on the wavelength of light and the size of the obstacle. So it matters on the barrier or the obstacle when the light will pass through. How is the wavelength of the light is being diffracted? Also, the smaller opening, the greater is the diffraction of light as shown in diagrams A, B, and C below. The longer the wavelength, the greater is the diffraction of light, as shown in the diagrams D and E. So these are now the examples of diffraction of light. That one, wherein the sun is being trapped by the clouds. Another one, the sun is being trapped, or there is an obstacle, which are the trees wherein the light is being diffracted. And of course, talking about diffraction, always remember that the light is being diffracted because of the obstacle or the barrier that traps the light. Let's proceed to number 4, and this is interference. When we talk about interference, this is the result of the superposing of waves from different sources. If you examine a shadow formed by the diffraction of light, you will see fringes on the edge of the shadow. There are two types of interference: constructive and destructive interference. So when we talk about constructive interference class, this happens when two identical parts of the waves meet, such as a crest of one wave meets the crest of another wave of the same wavelength. This would result in a new wave with the same wavelength but twice the amplitude. This is the example of constructive interference. You have there wave 1, wave 2, and the combined wave. Of course, there is what? Destructive interference. Another example. In illustration 1, the sound is reinforced. Two waves are peak aligned to peak. The second one, sound is cancelled out. Two waves are aligned peak to trough. So when we talk about destructive interference class, this happens when two opposite parts of two waves meet. For example, a crest of one wave meets the trough of another wave, which would result in the cancellation of the two waves. So this is another example. In phase 1, we have constructive interference. Another one, the 180 degrees out of phase. That is an example of destructive interference, wherein in the destructive interference, there is the cancellation of the wave. This is different from the constructive interference. This is the example. You have seen there the constructive and the destructive interference of the wavelength. Another one, there is also a constructive and destructive interference of the wavelength. And the last one, of course, you have seen there the constructive and the destructive interference of the wavelength. Okay? Have you understand the difference between the two types of interference? Constructive and destructive interference. Do you have any questions, class, with regards to our discussion this morning? None? So if there is none, I have here 3 questions for you to answer. First question, how do dispersion, scattering, interference, and diffraction of light prove the wave nature of light? Why? Support your answer. Anyone from the group? Yes, support? Very good. That is the correct answer. So in question number 1, when the wavelength of light has the same size as the object, diffraction blurs the image. When wavelength of light is larger than the size of the object, there is no image seen. When this property was observed in the visible light, it was considered as clear proof of the wave nature of light. Let's proceed to question number 2. Yes, Abraham? Have you observed different colors produced by the thin surface of soap bubbles when illuminated by natural or artificial light? Sources? Why? Elaborate your answer. Yes, Abraham? Very good. You are listening to our discussion. So, in question number 2, yes, of course, we can observe the different colors produced by the thin surface of soap bubbles when illuminated by natural or artificial light source because the reason behind this dynamic interplay of colors is wave interference. There is the presence of constructive and destructive interference. This shows that light have wave-like properties. For question number 3, from the illustration below, Sebastian places a pencil in a glass of water and observed that the pencil appears to be broken. How would you explain why the pencil appears broken? Support your answer. So this is the illustration wherein the pencil is inside the glass. What really happened and what observation could you give? Anybody from the group? Yes, Ruden? You raise your hand. Very good. You're really listening to our discussion this morning because you got the correct answer. Therefore, in the illustration given, the reason behind why the pencil appears broken because of the light rays are bent by the water in the glass. That is the reason. Is there any questions, clarification with regards to our discussion? None? So if there is none, so let's proceed to the next one. So today class, what we have experienced? Very good. We experienced COVID-19. So today we are amidst pandemic and we really experience it. If someone suffers pneumonia, will undergo the physical x-ray to know the real health situation. If the x-ray machine is about to operate, we observe that it produces radiation of light, right? The light travels in a straight line. It may be scattered, reflected, and diffracted, going to the body part portion of the body of a person. The results will determine if a person who have pneumonia or not. If the results reveal pneumonia, the doctor will refer the patient and undergo swab test or rapid test to really confirm if COVID-19 exists in that particular person who have underwent the so-called what? X-ray. Our world experienced this COVID-19. Amidst this COVID-19 pandemic, we are reminded to stay at home, always wear our mask all the time, and observe the social distancing. Based on the related study in the State Health Department, found sunlight therapy, it could be scattered, diffracted, and dispersed of light is to be the most valuable factor in reducing mortality. See, it will decrease fatality of hospitalized patients from 40% to 13%, boosting flu immunity among physicians and nurses, and overall boosting the outcome of vaccines, which then we are here in the early stage of the development. The benefit of exposure to the healing rays of the sun was so obvious that it became a common form of treatment against tuberculosis, another respiratory disorder, as well as one infections, psoriasis, acne, vulgaris, rickets, depression, jaundice, and a host of other diseases. So it means to say that through sunlight, it could really help sometime to what? Decrease the fatality of the hospitalized person having this COVID-19. So always remember to stay at home and always wear your masks when you go out in your respective houses. Is it clear, class? Anyone? Do you have something to say? None? So let's proceed now. Okay? For me to know what have you learned in our discussion this morning, we will be having the wrap up, and this is an activity called Let's Identify. So just stay with your group because this is a group activity. So kindly open your self-learning module on pages 11 and 12. So you have there the activity. So this is now the activity class. You have there the brief description. What you are going to do is to classify this particular definition, whether it is dispersion, interference, scattering of light, and diffraction. So you are given 4 minutes to do the activity. So the time starts now. Okay, 30 seconds left. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Time is up. Okay, so let's proceed now to the presentation. So may I call in the group 1? Just present your answer. Very good, group 1. Let's give them a hand, please. Let's proceed to the group 2. Congratulations for the job well done, group 2. Let's give a hand to them. Okay, the last group, group 3. Amazing. Congratulations for the job well done, group 3. Let's give a hand to them. It means to say that you really know our lesson for this morning. In that case, did you know that in biology, diffraction effects are sometimes not helpful when viewing objects under the microscope? When the wavelength of light has the same size as the object, diffraction blurs the image. When the wavelength of light is larger than the size of the object, there is no image being seen. See? That is in biology subject. Another one, in TLE, especially in Gulayan sa Paaralan, you have planted different vegetables and even crops. Does it need light? Yes, of course. Plants need light in order to survive and produce their own food. But sometimes, you have noticed that there are plants that cannot produce sufficient or enough food. That is because of the presence of the light. The light may be scattered, diffracted, or being reflected because of the barrier that may trap the light for the production of more harvest. Okay? Okay? For me to know what have you learned in our discussion this morning, we will be having the wrap up, and this is an activity called Let's Identify. So just stay with your group because this is a group activity. So kindly open your self-learning module on pages 11 and 12. So you have there the activity. So this is now the activity class. You have there the brief description. What you are going to do is to classify this particular definition, whether it is dispersion, interference, scattering of light, and diffraction. So you are given 4 minutes to do the activity. So the time starts now. Okay, 30 seconds left. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Time is up. Okay, so let's proceed now to the presentation. So may I call in the group 1? Just present your answer. Very good, group 1. Let's give them a hand, please. Let's proceed to the group 2. Congratulations for the job well done, group 2. Let's give a hand to them. Okay, the last group, group 3. Amazing. Congratulations for the job well done, group 3. Let's give a hand to them. It means to say that you really know our lesson for this morning. In that case, did you know that in biology, diffraction effects are sometimes not helpful when viewing objects under the microscope? When the wavelength of light has the same size as the object, diffraction blurs the image. When the wavelength of light is larger than the size of the object, there is no image being seen. See? That is in biology subject. Another one, in TLE, especially in Gulayan sa Paaralan, you have planted different vegetables and even crops. Does it need light? Yes, of course. Plants need light in order to survive and produce their own food. But sometimes, you have noticed that there are plants that cannot produce sufficient or enough food. That is because of the presence of the light. The light may be scattered, diffracted, or being reflected because of the barrier that may trap the light for the production of more harvest. Okay? To deepen more your understanding of the discussion that we have this morning, I have prepared here the differentiated activity for the application of your knowledge based on the discussion that we had. So, you have already your group. For the group 1, the activity that you are going to do is to compare and contrast dispersion, scattering of light. That will be your activity, and that will be presented by group. Next, for group 2, you are going to make a poster and slogan showing dispersion and interference that you have observed or seen in the community. Same also with group 1, you will present your output. And for the group 3, you are going to paint me a picture. Group will show a paint me a picture of diffraction and scattering of light. Same also with the two groups, 1 and 2, you are going to present your output. You are given 10 minutes for the preparation of your output. And for you to be graded of the presentation, so this will be the rubrics. First, for rubrics for the presentation. So please be guided because the group 2 will grade the group 1. Another one, rubrics, poster, and slogan. So the group 2 will be recorded or graded by the group 3. And the last, for the compare and contrast, of course, the group 1 will grade the group 3, of course. So those are the what? Rubrics in presenting your output class. Okay? You may start now. The 10 minutes begins right now. Okay? You still have 30 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Time is up. So it's time to present your output. Let's start with the group 1. Group 1, take it now. Wow, very good. Congratulations, group 1. Let's give them a hand, please. Now, let's proceed to the group number 2. Very good, group 2, for that very nice performance. And the last one, the group 3. Amazing, group 3. Congratulations, students. You did a great job in your presentation. That really means that you really understand our discussion this morning. So this time, let's have an assessment first. Question number 1. This is a multiple choice and I will be giving you 5 seconds to answer. Question number 1. Interference of light is evidence that A. Light is a wave phenomenon. B. The speed of light is very large. C. Light is transverse wave. D. Light is electromagnetic in character. Start. 5, 4, 3, 2, 1. Stop. The correct answer is letter A. Let's proceed to number 2. This is the example of dispersion of light. A. Rainbow. B. Shadows. C. Blue sky. D. White clouds. Time starts now. 5, 4, 3, 2, 1. Time is up. And the correct answer is letter A. Rainbows. Question number 3. These are examples of phenomenon of scattering of light except A. Sky appears blue at midday. B. Sky appears reddish in dark. C. Rainbow after the rain. Start now. 5, 4, 3, 2, 1. Time is up. And the correct answer is letter C. Questions number 4. How does diffraction work? A. It goes through water and air. B. Is a beam of light stopping at a wall. C. It bounces off light. D. Is the bending of light as it passes around the edge of an object. 5, 4, 3, 2, 1. Time is up. And the correct answer is letter D. Let's proceed to the last number. Number 5. Why is the component of color in a rainbow can be seen when light passes through a glass prism? A. Phenomenon of scattering of light. B. Phenomena of dispersion of light. C. Phenomena of reflection of light. And D. Phenomena of diffraction of light. Start now. 5, 4, 3, 2, 1. Time is up. And the correct answer is letter B. Okay, let's see who got the perfect score. Can you please raise your right hand? Who got 5? Anyone? Wow! Most of you got the perfect score. Very good. Congratulations, students, for the job well done. It really means that you are listening to our discussion this morning. And before we will end our discussion, I have here an enhancement or your assignment to do at home. You can open this one in your self-learning module, pages 15 to 16. So what you are going to do is to perform the activity called double slit experiment. Just follow the procedures, and after which you are going to answer the 3 guide questions. Okay? Questions, students? If there are some clarifications, I will cater your questions with regards to your enhancement or assignment. Students, I want to hear. None? Very good. Good job, students. So let's give a big round of applause to ourselves, students. Wow, congratulations. You did a great job. And this is the last time that I am going to speak here in front of you because we ended our class and it's summertime. Yay! Congratulations and thank you, students, for listening. Bye-bye!